Yeah, so a over 2 is log base 2, so half of base 249, right?
Yeah.
2b is 2 times log 9, 6. Is that right? Minus 1, yeah?
Yeah.
So there's not a lot of things that are happening, but can you see this is already, it seems like psychologically this is pleasing, right?
Yeah.
Because half goes into the power there. It's a square number, right?
Yeah.
So it means it's kind of weird, but like it means you've done the right thing psychologically. Because someone made this test, and for this to be, that's 7, right? And look, it's getting closer to 7. So it's not a, and the 2 goes inside to make it 36.
Yeah.
I guess, yeah, the 36 now is related to 9, whereas 6 is not. Right? So what can you do next?
Should we simplify the base of the second one to log 3?
It's hard to change the base, but the fact that you have 36 here, I mean, it's 9 times 4, right?
Yeah.
I mean, the only reason I see this is because you have a 1 here that's waiting to cancel with it. See, like, so you have log 2, 7, right?
Yeah.
This is log 9, 4 plus log 9, 9, right? Which is 1. And 1 minus 1 is 0.
Yeah.
So it's just now log 2, 7 times log 9, 4, yeah?
Yeah.
So basically what's happened is you want to now show log 3, 7 is equal to log 2, 7, right? Over log 9, times log 9, 4, yeah?
Yeah.
You see that? Yeah. So now we want to show if this is true. It's equivalent to what we were asked to show, yeah? Actually, this has a further simplification. Can you see it?
Which one?
This expression.
4 can be cancelled. 2 squared.
So 4 can be 2 squared, right?
Yeah.
So that's 2 log. Yeah? See anything else?
Minus 3 squared.
Yeah, but the base is hard to change, you know?
No, I don't.
Yeah, so... But we will eventually change the base. It's just maybe not right now. Something more. They said this 9... Sorry. It's this 2 and this 2, yeah?
Yeah.
So what, because log can go in the power, yeah? So you can go 2, and then it's log 9, 2, right?
Yeah.
To that power.
Oh, I don't. How can you do that?
Because this is just a number. It's timesing the log. It goes in the power. Just like how this half went into the power,
Okay. Yeah.
right?
Yeah.
This number goes in the power.
Yeah.
And that's a nice thing to do because now it's
7.
just 7, yeah?
Yeah.
So let me just see this. So now it's 2 log goes 9, 7, yeah?
Yeah.
Now we're getting real close, aren't we?
Do we change the base now?
Yeah, I guess now you can kind of change the base. So, yeah, so what would this change to?
Log 9 7 squared.
Hold on. So this doesn't change the base.
Or log 3 squared 7 squared.
Yeah, so this is log. So can you apply the change of base to this log 9 and 7? So you get 2 times. Hold it. 2 times. So how do you change the base here?
Oh.
You want to change it to 3, right? So you want log base 3 of 7, yeah?
Yeah.
Divided by... Changing to log base 3, right? So it's log base 3. So the 2 is not changed, right?
Yeah.
We just leave it outside. We're changing this to log base 3. Yeah?
Yeah.
Now we did it before, remember? Change of base formula.
Log 3 9.
Log 3 9, yeah.
And that 3 squared.
Yeah.
So 2 cancels out.
So this cancels, right?
And log base.
Yeah. That makes sense?
Yeah.
Okay, good. What's next? One.
Yeah.
How many positive integer powers, not including 0, of 7 are less than 10 to the 9? 10 to the 9. How many positive powers of 7 are less than 10 to the 9? So I guess, like 7 to the 1, 7 to the 2. So whatever the biggest power is, like 7 to the a,
Yeah.
that would be the answer, right? Because there's a of them. It'll be 1, 2, all the way up to a. So it's clear, can you see it clearly that 7 to the 9 is less than this? Just because 7 is less than 10. Yeah?
Yeah.
So that's obvious. So the answer should be 9 or more. Yeah? How do we go further? Yeah, so what power of 7 is just less than a billion, you know? I mean, this kind of question it's much easier when you know logs, because you can just straight up equate them, basically.
Yeah.
So you can do 7 to the x equals 10 to the 9.
Yeah.
Wait, are you allowed a calculator for this?
I think the one that's used log.
You might still need a calculator, depending on how you do it.
Do you do log base 10?
Yeah. So you can just try to solve for x, right?
Yeah.
So if you do log base 10, you can get x log 7 equals 9, right? So x is equal to 9 over log base 10, 7. So it all depends on this numbers. So what's log base 10 of 7? So log base 10 of 10 is 1, right? So log base 10 of 7 should be less than 1, you know? The square root of 10, so is like 3 something, you know? So 7 should be more than that, you know? It should be more than half, basically. Yeah. I guess if you had a calculator, it'd be really easy to figure out what this is. So the question is, are we allowed a calculator?
I think for a calculator you could figure it out. For a calculator you get decimal and then like.
Yeah, or you could just power up to 7.
Yeah.
So I'm not sure if we're allowed a calculator or not. Okay, but this suggests, so like if this is bigger than half, right?
Yeah.
Then this number is smaller than 18. Yeah.
Yeah.
So I mean, then the question is it's obviously more than it could. So x is more than 9.
Yeah.
Less than 18. So there's, so many possibilities. How else can you do this? If you had 7 squared is 49. 49. Yeah. Twos and fives. Yeah, they're not so easy to divide.
I think we are allowed to use a calculator.
Oh, really?
Yeah.
Oh, okay. Well, then we don't even really need logs. I mean, you just do 7 to the power of 10.
And guess it.
Yeah. Right? But yeah. How would you do it by hand? Let's see. So 7 squared is 49.
Yeah.
So 7 to the 10
Yeah.
would equal 49 to the 5, right?
Yeah.
And so 40, if we compare 49 to the 5 to 10 to the 9, right?
Yeah.
We can try to treat them like 50s maybe. So this would be like 100 times 100 times 100. That's 10 to the 6, right?
Yeah.
That's 10 to the 8 times 10. That's 10 to the 9, yeah?
Yeah.
And there's 49 of these. So each of these will give you like half, half, you know what I mean? Half, half. So this is less than half times half times half times half times 50 on 10. So 5 over 10. 5 over just 5, yeah?
Yeah.
But there's 16 of these and there's only 5 of those, right? So this is less than 1. So 7 to the 10 is less than 10 to the 9. But I think if you had 7 to the 11, it might be just enough to go over. Because this is really 5 over 16, right?
Yeah.
If you had 7 to the 11, you times that top by 7. This would be like 35. See? The answer is probably 10. Yeah, so 7 to the 10 is definitely under. And 7 to the 11 is probably over. Yeah. I just got a calculator today. Let me just. So 7 to the power of 11. One, two, three. Yeah, 7 to the 11 is over. And 7 to the 10 is under. What else?
Question 2.
Question 2. X. So you want to find k if x to the k plus 3 equals e to the 7 log x. So this is meant to be true for all x greater than 0. Oh, I think you can do this one. This is quite similar to the other one. Do you remember? The one with the a. There was like an x to the a times x to the 4. You remember that? Yeah, so remember what we did last time? We put the 7 into the power.
Yeah.
And then this is log base e, right? So then it just becomes x to the 7 equals k plus 3, right?
Oh.
Remember that?
Yeah.
Yeah, so then you can get
K equals 4.
yeah. I think we might be able to. So when something works for all, like lots of values, all values of x, remember I'm telling you that you can always make. There's a lot of the times. Sometimes you can make a very like inspired choice of x to replace all of them. Like it might give you enough information. So in this case, I think you would let x be e. So what if you have x equals e, right?
Yeah.
What would happen?
To be x k plus x to the power of k plus 3
E to the power of k plus 3.
e to the power of k plus 3 equals e 7 ln x ln e.
Yeah. What's that?
1.
It's just 1, right?
Yeah.
This is just e to the 7, e to the k plus 3.
K equals 5.
Yeah. So that will save you the difficult manipulation. But I guess you have to do something. So k equals 4.
Yeah. Next question B.
Okay, so s equals half 2x plus 2 to the minus x. D equals half 2x minus 2 to the minus x. Question says, oh, how much of this is to find a whole bunch of things, yeah?
Yeah.
So we're looking for SD, S plus D, S minus D, and S squared minus D squared.
Yeah.
Yeah?
Yeah.
Yeah. Yeah, I guess SD is probably pretty easy because it's like a sum by difference, yeah? So it's a quarter. So it's this squared minus this squared, yeah? Yeah. So S plus D has a nice thing because these cancel, right?
Yeah.
You see what it is?
Just 2 to the power of x.
Yeah. S minus D. Hmm.
2 to the power of negative x.
Yeah. Can you actually see that if you, so this is some kind of funny thing. If you change x to minus x, right?
Yeah.
S doesn't change. And D becomes negative D.
Yeah.
You see that? So if you apply that to that, it becomes this, doesn't it? So you could just also subtract this to minus x. Okay. So it seems like you can do these ones. You know how to do this one?
Oh. Do you just square root?
Well, I don't think you can't really be stuck on these because there's only so many terms. So if you ever had to really like, if you didn't know what to do, I think you would just have to go for manual labor,
Yeah.
right? Yeah, like some people think if you do it the long way, it's wrong, so they never want to learn it the long way. But if you don't do it the long way, when you don't even have a way, then I guess you never really care about the solution in the first place. Yeah, so I think it's always good to try and get it, no matter how tedious it is. But here it's also a difference of two squares. Yeah,
Yeah.
so it's just that times this. So then that's times that. It's just one, right? Okay. Yeah, no, I definitely believe in hard work. You try to avoid it if you can, but
Yeah.
not if you can't. Yeah. This is
Discussion.
rewrite the formulae for s and d as a quadratic in 2 to the x. Hence express x in terms of s and in terms of d, where x is greater than 1. Do you know what that means? So they don't want this minus 2 to the x here. So like they want 2 to the x to be equal to y kind of thing. And you want s to be like y squared plus y.
Okay.
You know what I mean?
Yeah.
So then that should be obvious then. So in this case, this would be like half y plus 1 on y, right?
Yeah.
I don't know what they... It's a quadratic. That doesn't really make any sense. Yeah. This is half y minus 1 on y. I don't really think you can... Or maybe they want the quadratic equation. Oh, so we're allowed to use s and d as coefficients.
Okay.
So like then it'd be like, so this would become, like 2s y equals y squared plus 1. You know? And so it'd be y squared minus 2sy plus 1 equals 0. That'd be the equation. And this one would be y squared. You know what I'm talking about?
Yeah.
Minus 2 dy minus 1 equals 0.
Yeah.
Okay, and then you want to solve for x. You know how to solve for x?
Do you first like factorize the... Do you sub into x now?
I'm very confused. I just don't understand. It says hence, right?
Yeah.
In terms of s and in terms of d. Okay, so I think what that means is that it's in terms of only s, right?
Yeah.
Because otherwise you can just do this straight away with this. It was s and d. So I think you want to express it only in terms of s. So then the hence is coming from solving the quadratic, right? Do you know how to solve the quadratic?
Quadratic formula.
Yeah, I suppose. So what is it? Y equals
Negative b, so 2x plus or minus 4s squared minus 4 over 2.
no, so the most obvious thing is the 2's cancel, okay?
Yeah.
You get s or minus s squared minus 1, yeah?
Yeah.
Okay. But then remember y is 2 to the x, right?
Yeah.
So that would mean x is equal to you can solve that, right? Yeah. I mean, so if x is greater, so there's only one thing here.
Yeah.
If x is greater than 1, this has to be greater than 2, right?
Yeah.
So that might help us eliminate one of the solutions. But otherwise, it's, x equals log base 2 then. Yeah. So is one of these solutions clearly like less than 2? Like, or basically, is s minus root s squared minus 1 less than 2?
If s equals 1.
Huh? S. S is equal to this thing. So S is always bigger than, probably always bigger than 2. And that's 1. S squared minus 1. What is S squared minus 1? It's S squared minus 1.
Yeah.
It's D squared, isn't it?
Yeah.
Yeah? And so, see, can you see how, like, most people, if you just wrote x equals that, you're done.
Yeah.
And they wouldn't care, but you'd be wrong, right? So this D squared is minus D, right?
Yeah. But doesn't that mean 2 to the power of x equals 2 to the power of negative x?
So that doesn't work if x is bigger than 1, right?
Yeah.
So basically what we're trying to say is, so 2 to the power of negative x, yeah?
Yeah.
If x is greater than 1, is always less than 2, yeah? So that has to be excluded. So it can only be s plus. So s plus d is 2 dx, yeah? So that makes sense, yeah? Alright, and I'm sure you can do the same thing for the other part, yeah?
Yeah. Question. Listen.